We are still thinking about round things that rotate, and we just looked at pumps. Now we'll think about hydraulic motors, but we are moving on to a different place in the hydraulic circuit. We are now thinking about actuators. An actuator is something that does some work for you, grabbing, pushing, rotating, moving. A cylinder is a kind of actuator, and a cylinder, which we'll look at next week, converts oil pressure to linear motion. A hydraulic motor converts oil pressure to rotary motion. And here in this cutaway view of a hydraulic motor, notice these two ports here where oil can come in or go out. Can come in one, go out the other, or it could go the other direction. So, by the way, we're looking at a bidirectional motor here. You might want rotary motion in something like a conveyor. So here on the right is a conveyor where the head pulley is being turned by an electric motor. Here on the left is a conveyor where the head pulley is being turned by a hydraulic motor. This one on the left happens to be out in the yard at Peterson Pacific. So there's one of their hydraulic motors. Well, I'm attached to electric motors. I just like them, and I like belt drives, but so what? A lot of people like hydraulic motors. They're really easy to manage. You can change speed, you can change direction. It won't overheat like an electric motor will. You don't need all these V-belts and shivs and belt guards like you do on an electric motor, so it's just a more elegant solution, let's face it. And there are several flavors of hydraulic motor, just like there are flavors of pump. There are piston motors, and here you can see this is like a swash plate motor. Here's a bent axis piston motor. Notice the similarity with pumps. Here's a gear hydraulic motor. Again, looks like a pump. Here's a gerotor hydraulic motor. Looks like a pump. And in fact, there are a lot of similarities between hydraulic motors and pumps. And this is kind of parallel to what we run into with electric systems, especially in direct current, DC. You could wire a DC generator in one direction and it generates. You could wire it in the other direction and use it as a motor. Or you could take a DC motor and reverse the wiring and use it as a generator. Well, similar idea with hydraulic motors and pumps. And in fact, many manufacturers use the same parts, some of the same parts in motors and in pumps to cut down on inventory and because they're so similar. But a difference is bearings. So hydraulic motors have to drive loads. Let's look back at our, where were we? Let's look back at our conveyor. So there's a high torque here, the force acting on that pulley. So that's rather demanding. And so hydraulic motors need good quality bearings. Pumps don't have as much a demand, and so manufacturers can use lower cost, lower quality bearings. So what that means is you can go one direction but not the other. You could use a hydraulic motor as a pump in a pinch, but you cannot use a pump as a hydraulic motor because of the bearings. Now let's think about symbols. Again, we're thinking about how a thing that rotates is represented by a circle. So here is a circle with an arrow pointing in. Remember when we looked at pump symbols, a pump was a circle with an arrow pointing out because it was pumping oil out into the system. This is a symbol for a hydraulic motor. It has an arrow pointing in because, as you saw in that first slide, there's a port where oil comes into the motor, and that's what makes it turn. And then, by the way, this symbol here off to the side is the symbol for a return line that goes back to a tank. This is the tank symbol. You can see it looks kind of like a tank. So arrow pointing in, that's a motor, because oil is coming in to make the motor turn. It's very common to have a bidirectional hydraulic motor, as we saw in that first slide where there were two oil ports, and you could have either one the input port and either one the output port. So if you have a hydraulic motor like that, which you probably have, you use this symbol. It's got an arrow pointing in on each end. That's a bidirectional motor. Finally, here's our, on the left, here's our standard bidirectional hydraulic motor and good old fixed displacement. It's the same volume of oil no matter what. In the middle, here's our friend, the sloping arrow, representing variable something or other. So here is a bidirectional motor. It's got two arrows pointing in, so we know it's a motor. And here's the sloping arrow, so we know it's variable displacement. And then just to be thorough, here's the line, the return line going back to the tank.